really impressive results. I'm looking forward to try this area, actually. I hope I can get one. So, Wolfram, thank you for coming back. So let's start with a general question to both of you. So Raquel, I had to leave. So you both have talked a lot about learning. And so at this point, a question arises. So how can we integrate end-to-end solutions into industry? Do we need to certify them, and up to which degree? So who wants to answer first?
I mean, it depends on what you're doing. I think in automated driving, this is more critical than in spaces where you maybe do want to do like entertainment or using stuff for your pleasure. I mean, like it's similar to when you do face detection with your photo album. You know, then it doesn't matter when you have false positives or false negatives. Not too many, at least. You know, but in a self-driving car, you don't want to have false positives and false negatives. And this is actually what drives us crazy there, and what makes it all so difficult. And which is also the reason why currently these strong priors in forms of maps are so useful, because we are not yet there that we can basically replace these maps and models by perceptions. Although the stuff looks just amazing, and Richard, congrats to these results. This is just like.
But is industry giving some metrics that our algorithms need to satisfy in order to be deployed, or not? Are there any metrics?
I mean, in the end, it is the disengagement rate, right? This is what for self-driving cars, at least, right? This is what people thought a lot about, and I mean, there's all these numbers that like a human does a mistake, let's say every 80,000 miles or so on average. So this is basically where you need to be with a self-driving car in order to deploy it. Then if you accept that the car has human level performance, which is unlikely, so many people will even require that these cars are safer than human-driven cars before they accept all these things that are going to happen. And that somehow shows how far we are away from real level 5 and doing this in environments that are actually like unknown to these vehicles. On the other hand, when you look at like J.J. Rick's videos about the Waymo cars, right? And I really recommend people looking at those. This is J.J. Rick's, J.J.R.I.C.K.S. and then Waymo. You can actually see like plenty of videos where he takes the cars into really challenging situations, and it is amazing how far you can get. But still, we are not yet there.
Yeah. Richard. So
yeah, I think
the same question.
On the same question, I think that the bit that's most relevant for the area of augmented reality is one of trust with respect to the anchorability of data. So the ability to anchor content into such a map, which is one of the main applications of augmented reality. The ability for it to persist and it not have bias, and then all the other stuff associated with biased detection and so on that comes from not having training data that's basically spanning the full range of diversity. So I think when we think about trust, there's different sorts of trust, like trust of an online inference model, trust of like the consistency of a map representation for just say anchoring virtual content, and even, for example, trust associated with like is let's say if I'm going to do a physical search over a space, is this a modifiable model of reality by just anybody, or is there a way of securing that like this is the authenticated trustable model of reality? That is a really big unknown. So even for just the location space, i.e., could somebody come and corrupt a multi-user SLAM or distributed crowdsourced aggregated map? We don't have strong answers to that yet. There are usual answers, like if it's behind a secure compute cluster, then sure, but then you're trusting that particular organization with that data and it's trustable, versus actually things that are truly intrinsically trustable. So having representations that are truly trustable for distributed map updates seems to be like a key area.
Okay, another question we have, so we can start with Wolfram. What are we missing in automated driving? Better perception or better prediction models or something else?
Actually, both, right? So, I mean, we saw a couple of examples today where you could easily like fool systems. So better perception is still an issue. And then I think the really hard part are these what Raquel talked about, like making proper and joint predictions about ADO agents, like let it be cars or even pedestrians, and being able to make robust predictions is going to be super important for the robustness of cars. And I mean, the interesting aspect might be that if you are able to actually make good predictions about what others are going to do, then maybe we can even make good predictions about what the agent itself should do, you know. So why, like if you think about this as an imitation learning task, like how do you, like, can't you just learn from other drivers what to do best in a specific situation? And so if you are able to predict what others are going to do under the assumption, let's assume that this is an ideal agent, that's what the reinforcement learning setting is, then you should be able to become a perfect driver by just observing the world. And so that, like, looking into prediction is also super important, and but also extremely powerful. And then you can even use it then in simulation. You know, if you think about like ADO or agents in simulation, they're relatively simplistic with respect to their capabilities, these agents. And if you really want to have like interesting agents there, then probably, or lifelike agents, and you probably would have to learn them. Right? It's unlikely that you're going to be enough to program every behavior out there. Right? Yeah. They do this for games, but you know, but I think if you think about realistic scenarios or more realistic scenarios, traffic simulations, then you probably need to have some predictive power, which is basically simulation.
Richard, same question to you. So what are we missing?
So this is a really big question. You know, I started my talk sort of like with a quote from Craig. The interesting thing is that we see this challenge in that if we've got a task, it looks like, you know, teams of scientists working together with enough incentive, usually an economic one at least. I'm sure Wolfram and others can tell us as to like the value of self-driving cars and why it's such an important research topic, right? Same with AR, same with all these other areas. If you have a niche area, you can go and optimize it. So if we were only interested, let's say, in world-locking objects, then actually the representation problem of like what should a map be is pretty clear, and optimizing all the way down to like event-like cameras, all the way through to what should or shouldn't go on a server because of privacy, you know, restrictions and so on, becomes super clear. But if we want a holy grail of actually, in principle, a trustable, authenticated, and actually valuable model, like this asset for humanity, which we then go and mine, you know, 50 years later, you've got this asset, and actually you're still pulling out valuable information about it, a true science on top of, you know, predictive model of reality that is shared, then we're lost, right? Because we're still in that space, in that sort of hierarchy of models. We're really in the sensorially predictive space. If you add a task, you know, as Wolfram and Raquel showed, at least for say self-driving cars, you can start to add action, you can start to add prediction, you can start to do predictive model control, and it really works, right? And you can keep the model up to date sufficiently, and you don't really need a HD model from like, you know, just pro rigs, etc., because actually, you know, there's advantages to not doing that as well. So it's one of those things where when we open it up again, it's kind of like AGI. We don't really know what a representation or substrate could be. That seems to be the biggest challenge, if I'm talking from a scientist point of view. From the application just for AR point of view, we truly are at the limits of diffraction limited sensing. You know, the point at which for a given wavelength of light, you really can't resolve the resolution because your aperture is too small. You know, in real terms, this is 1.22 times lambda divided by the diameter of the aperture. And if you put those in meters and see, well, hang on a second, what's that on like a glasses, unless you want big chunky sensors that look like this, right? And if you don't want glasses that look like that, literally you're going to have this problem that you get nothing like what you can get from a car, where you can have nice, big, beautiful sensors and so on, right? And okay, how do we solve that? You're at the physics limit. Same with what you can do with compute. So at that end, we're actually at the limit of what you can do on a real world device, what you can sense. And hence we're back to what if there were a model, you know, and it's kind of this circular, to solve that, we think you need a model that's good enough.
Okay, thanks. So we are actually running quite over time by 20 minutes. So I think we should conclude. At this point also, Antonio and Marcus, you can jump in. So anyone can make conclusive remarks. So Antonio, Marcus, would you like to add anything?
I mean, like very shortly, I think it was like a super interesting workshop. We heard several opinions from several experts in completely different fields. So we really learned a lot of this. I think it was a success. That's my only closing remark.
Antonio, I completely agree with what you said. And first of all, thank you to you for taking the main load of organizing that workshop. That's really a big plus that you did there. I really appreciated today the diversity of the talks, and I as well see how interesting it is that we work on similar problems, particularly in this domain of self-driving cars, perception. It always boils down to similar problems, and I really, really appreciate the diversity on one hand, but that we see or that we work on the same issues in the end.
Yeah. Any conclusive remarks, Richard and Wolfram?
Richard, you go first. I was also first.
Thanks, Wolfram. I'm actually, yeah, I'm really happy about the workshop and seeing the diversity. I also think that the fundamental question about, like, you know, maps that came up again and again, or models, is one where, you know, maybe at some point we can think about it. Very inspired by Luca's talk because of the openness of, like, the potential, right? I mean, that's the academic side, basically doing what we're doing, but not for a given application, but perhaps more roboticsy than AR and so on, right? But what if, as like a community, we would start to think about the potential of an open model of reality platform, you know, because cars need it, AR needs it, you know, drones need it, and so on. And yes, you know, not everyone can go and deploy it, but actually the concept of it for simulation and so on seems valuable. So I was inspired to see those connections, as Marcus said, throughout the talks.
Mm-hmm. Wolfram?
Yeah, I also, first of all, I want to thank the organizers for putting all this together. This was a fantastic mixture of talk and very, very well chosen. I actually got really inspired by today, and I think I met Richard 2 years ago. Like, was it Los Angeles, or I think it's somewhere in that area, in that space. And when I went back, I was also very inspired, and we should do this more often. And I think in particular the cross field character of this workshop was pretty amazing, and I think it would be good to think more often and across the fields and understand where we are and what the solutions are that people work on in these individual fields. I think in industry this is often called siloing, and we should more often get out of our silos and talk to each other more, which is difficult in this pandemic times, but hopefully over soon. But really like it. Thank you.
Yeah, I also agree that it was very interdisciplinary, and actually this is a key point in research, that we should get contaminated, but also look, you know, for new contaminations. I would like to actually thank a lot Antonio, because he was the main organizer. He finished his PhD and now he's actually a doctor since a few weeks. So thanks a lot, Antonio, who put up the whole agenda. And thanks to the other co-organizers, Marcus and Luca, who just left. Thanks to you, Richard and Wolfram. And then at this point, thanks to all the attendees for being with us today. We reached over 200 participants. And so yeah, all the recordings and the slides will be made available. We will also ask you to share the slides, and then stay tuned for the next workshops, and hopefully we can meet each other again at the next Congress.